Hello everyone, we are starting our last section of our curriculum 24D where we're talking about quantiles or k-values within the normal distribution or within the normal standard distribution. Okay, so let's just recall for a moment here what we have been doing so far. We've been looking at the standard deviation, the normal distribution or the standard normal distribution. They both have the same shape with the same percentages of data within each range of the mean standard deviation. So let's remember this is where the mean would be, one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean, and back here, mean minus a standard deviation, the mean minus two standard deviations, and the mean minus three standard deviations. Okay. Now let's think about it in context of this question that we're talking about at the beginning of this section in the textbook. Consider a population of crabs where the mean length of the crabs is 70 millimeters and the standard deviation is 10. Okay, so now we know, as long as this is normally distributed, we now know that we can put these numbers in here. 70, a standard deviation of 10, therefore 80, 90, 100, and back here 60, 50, 40. Okay. Let's recall. I'm not going to finish reading that for a second. Let's recall. What we have been doing, the types of things we've been doing so far is finding probabilities. Okay, so far we've been finding probabilities. Okay, so up till now, that's what we've been doing. Things like probability that x is greater than or equal to 60 equals what? Okay, well, here's 60. That means we'd be looking for this entire area under the curve 60 and above, because x greater than or equal to 60. And we could add all of those parts of the normal distribution up and get our answer here. That's what we've been doing so far, either with numbers that are easy to use, that are exact standard deviations away from the mean, doing it without a calculator, or with a calculator with any values. Okay, now what we will be doing is the opposite. Now we will be looking at something and saying, what's the probability that x is greater than or larger to what number if that probability is 95%, for example. Okay, so before we were looking for, we knew the x value and we were looking for the probability. Now we know the probability and we're going to be looking for that x value. These x values we call quantiles or k-values. Okay, because this is basically an opposite operation from one another, what we'll be using on our graphing calculator is inverse norm. Inverse normal. Okay, so that's what we'll be looking for in our calculator now. All right, so for example, the rest of this question says, a biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. Therefore, he asks this question. 95% of the crabs have lengths less than what? Okay, so opposite of the way I wrote it down here, we're looking at a specific example now. So they're saying, what value of x are all the values less than, okay, that gives us 95%. So in this case, we're looking for 95% and down. So we're looking for a value somewhere in here. Somewhere in here. We're looking for a value somewhere in here. So our answer should be around 80. In between 80 and 90, because we need 5% to be left up here and only 2.28% is there. So it's going to eat into part of this part of between the 80 and 90. Okay, so our answer should be between 80 and 90. What we actually do in our calculator for this is get the old trusty TI Inspire out, and we say we say menu, probability, distributions, normal, inverse norm. Okay, so if we know the probability, we're trying to find the k-value, we use inverse norm. Now it asks for the area, and this refers to the area under the curve. Okay, so that referring to calculus, the area under the curve, that is the probability. So in this case, we're looking for 0.95. Now, we can only do less thans from the calculator for this. Okay, we can only do less thans. So keep that in mind. We'll talk about that in subsequent videos. The mean was 70. Standard deviation was 10. And press OK. And 86.4 would be the answer. 86.4. All right, so here we go. 86.4 would be the answer there. So here we would write, this is what we'd write out in the beginning, except instead of a question mark, we would put a K here. Okay, so using proper notation. The probability that X is less than or equal to K equals 0.95. Okay, now we can only do less thans. So if we're actually looking for greater than, we have to find the less than instead. We'll talk about that in subsequent videos. Here's the notation you could use. Inverse normal, just write inverse norm, and then write what you had to write down. We had to say the area, which is the probability. We had to say the mean and the standard deviation, and therefore we calculated K to be 86.4. So 86.4 millimeters. So this, in the context of this question, that would then mean 5% of the crabs are bigger than 86.4 millimeters. 95% of the crabs are less than 86.4 millimeters. So that's the value that they would use as the limit for being able to harvest crabs. Okay, quantiles. Have fun.